so now the final thing to know is the domains and the ranges of these different functions. So here we're looking at the one for sine. The range is this up and down thing, or range is normally related to y, and domain is related to x. So the value of x that the function can take, the values of y that the function can take. So for sine, it will normally be between -1 and 1. Okay, so this will normally be theta. Okay, so we can say that -1, right, is less or equal to sine theta, because this is a function, or y, you can put y here, or less is equal less and equal to, or equal to 1. So that will be the range. The domain here is going to be this to there, which is -infinity. Then we can do theta less equal to infinity, right? Okay, so similar thing applies to cosine, right? So it'll be similar, where we'll have this aspect, okay, and that aspect. So meaning that we'll have -1 less or equal to sine theta, and this, like I said, could be y, because this is y. Then less equal to 1. Then the angle itself will be theta less equal to infinity, like that, because you can look at this. This is going to infinity, that's going to infinity. It doesn't have where it actually stops. You have to limit the range, the domain or the range, for it to be limited. Okay, so this is what we have. Actually, you have to limit the range, the domain, not the range. Okay, so now we go to the tangent. This one is a little bit tricky because it doesn't have a continuous function. So you see that here you have 1, there you have 1, you can have 1 this side, and so on and so forth, right? Now, the thing to note is that it starts from the origin, almost like this one here, and then look at the gaps. You have pi over 2. This, we said, if we convert, is 90 degrees. That will be 180 degrees. Okay, this will be 270. This is minus 180 degrees. So you will see that, sorry, this is minus 90 degrees. Okay, and so you will see that this doesn't cross, the graph doesn't cross this one. So these are known as asymptotes. Okay, we don't cross those, so we don't touch this. In fact, we can say that the function is invalid around these numbers. Now, what is very important is now what happens to your range and what happens to your domain. You see that the range goes up and down to infinity. That's why we're saying that the range is infinity, negative infinity to infinity, right? What about the domain? Now, the domain is very specific. It's always between these for a period of about 180. So it's from here to there, and then here it will be from here to there. So you see these jumps, it's not continuous because of these asymptotes. So what are we going to say? We're going to say that it's not equal to pi over 2, which is pi over 2 plus n pi. So meaning that every time we add 180 to this, we'll find an invalid spot. Every time we add 180 to 90, we'll find an invalid spot. Okay, so this is what it means. So you see that this is 90 degrees. If I add 180, it goes to 270. At 270, we found that it was invalid. If I take away, in fact, it's plus or minus. If I take away 180, which is 1 times pi, it takes me to negative 90. Okay, like this, 90 minus 180. So this takes me to negative 90. Negative 90 is negative pi over 2. So it takes us to this point where we find an asymptote. So there it's not valid. So the domain will be something like that. Okay. So essentially, these are the ranges and these are the domains. So now we can proceed and do a few equations and try to solve. Since now we know the conversions, we know the reference angles, we know the signs in various quadrants, then we know the domains and the ranges. So this is enough information for us to solve trig functions now. Okay, all right, all the best.